Hello and welcome back to our quick start guide to scientific computing. And in this lesson, we would be building on what we studied in the first lesson. Now, in the first lesson, we spoke about the structure of our C program, the variable declaration and assignment, and then we printed and then took inputs from users. Now, in this lesson, we would be paying attention to a task, or would be performing a task. That's the assignment. So let's go straight to the assignment. Now, the first, we are to write a C program to compute the formula V equals U plus AT. That's the formula for the final velocity, given the initial velocity, the acceleration, and time in seconds. And then the second task is to write a C program to compute the formula for simple interest. That's the principal times rate times time all over 100. So let's see how we'll do it. Now, first things first, when you are given a task like this, the first thing to do is not just to jump in straight and then start programming or start coding. You first have to go and then look at how to plan your work, and then after planning, you realize that your work becomes easier to do from there, or the programming becomes easier. So to plan, let's say we are looking at the first program for the velocity, right? Now, velocity, we said it is V equals U plus AT. So we first have to look at our inputs, right? And then our outputs. Now the question is, would we be receiving inputs or taking inputs from user, or would be using our personal inputs? And then if yes, what inputs are we going to take? So realize that the initial velocity must be known, right? The acceleration A must also be known, and then the time too should be known. Now, another question is that these inputs, which type of variable would they have, or which type of data are they going to contain or hold? And then we can see that the initial velocity could actually get decimal, so we can actually use the float or we could actually use the float or the double data point or data type. And then acceleration could also use the same thing. And then time in seconds, here we would pay attention to seconds, so the SI unit. So would say use integers here. You could also decide to use floats, but then here we'll be using the integers here for time. And then our output, what are we going to get? It's going to be the velocity, the final velocity, and this is also going to be a float. So now we know that in this program we'll need to declare 4 variables, right? Now, these 4 variables is going to be the variable called U, that is for initial velocity, the A, the T, and then the final velocity. And then we are going to receive this from the user and then output this to the user. So this is going to be our output. This and this are going to be our inputs. So after we receive these 4 variables, this will then compute or perform this computation here. So we'll then decide to compute, let's say, U plus A star T. The computer doesn't know what times is or AT means, so it means I would have to perform this computation and then print what? Our output V. So you print a certain float, right? V to the screen for the user to see. So basically, this is what we are going to get from the first program. So now that we know that we need 3 variables that will receive floats and then integer respectively, and then output another variable that is the float. Now we can now go and then create our C file and then start programming. So we open our terminal and then create our C file using our best editor That's the vim. And then this one, we call it probably velocity.c, right? And then we hit enter. So this creates a file, velocity.c for us. So you press I to insert or go into the insert mode. And then the first things first, we include our standard library. So include the standard input outputs header, and then declare our int main function. We won't be returning anything, so I'll put my void there. And then now we said that we will need to declare 3 variables. So the u, but then that's a float, so I can decide to do float. Now we could also decide to give it an initial value, so that just in case the user doesn't, or we don't take user input from the user, we can just use those values to compute. So we can say our float u to be equal to, let's say 2, our initial velocity to be 2 meters per second. So, and then you'd have to give a comment to say that where u is what is the initial velocity, right? And then we declare another float, say a, and then assign it, give it an assignment. So that will be a to be, let's say 3, and then we'd have to first terminate this line as well. So 3, and then this is what. It is good to comment, because for now you know what the A and the U and the other stands for, but then when after some years or after some months, when you open this file, you keep asking yourself, what is this variables for? So A is for acceleration. Okay, now we want another one. We said the time will be an integer, so int and then t, and this t should receive, let's say, maybe 2 seconds, just in case. And then we comment t is for time taken for the motion. So now we have declared and assigned, given some values first. So if we want to take input from user, then we could still, but first we have to let the user know what our app is doing. So we say welcome to our velocity calculator, okay. And then from here we decide to print another one to take in the input. So please enter, or you can just say enter the value for your initial velocity, sharp velocity u. And then so you give it, so if you want it to print this output and then move to the next line, you can just give n and then use your scanf to take input from the user. Now so we have to terminate this now as well. So scanf, and then we are taking what? A float, so that will be %f, and then we have %f, and then we now give the address of where the u is, so address of u. So the next thing, we still do the printf, Sorry, there's an error with my printf here. F, exactly. So the next one is printf, and then this time around we are entering what? So enter the value for the acceleration A, right? And then we want it to move to the next line, and then we receive the input, so we scan F, and then the acceleration is also a float, so we take the float, so %F, and then the ampersand, the address of the variable we are storing. So let's say we are storing it at A, so we use that. And then the next one, or the last one, will be printf what? Enter the time taken for the, so time taken for the journey, or let's just say time taken or time spent, and then move to the next line, scan F, and then since this is an integer, we take %D and then give it the address of what? The time t. Now from here we could decide to compute, to make our v to be equal to u, as we said, plus what? A star t, right? A star t, and then we terminate it, and then decide to print our, so your final velocity v is, so the final velocity is also a float. Now if you want to show probably your answer to 2 decimal places or 3 decimal places, you can. So just say .2f, sorry, so .2f, and then move to the next line, and then we are, which variable are we printing? The v variable, so we end the line. Now let's save and compile and see whether we'll run into some errors. So we do GCC, right? To compile, we do GCC and then velocity.c. I want to save my output to velocity.x, so I will do that. I compile. Yes, I have an error. It says that v, okay, first print, that's print is not as allowed, and then another one is saying that the v is not declared first using the function. So let's go back here. Oh yes, we didn't declare the v, so we have to go and then declare the v, and then first let's change our print here, the first print here. So this is confusing if you are moving from Python to C, but then you'll be fine. So print f, and then here we would have to declare another variable, let's say float. We could decide to just declare it and then assign it straightforward like this if we want. So like float, then v equals that. But then the question now is that it's all about your choice, but then I would advise that we keep everything clean by showing that, or by declaring all our variables at one side, right? So I want my float and then v, and then v first I'll give it an initial value of probably 0. Yep. And then now let's save it and recompile it and see. save, recompile. Now when we recompile, we don't have any error, which means that everything is good. Now, so let's run our file and see. Velocity.x. Welcome to our velocity calculator. Enter the value for your initial velocity. So let's say 2.5. Enter the value for the acceleration. So 3. And then time taken 2 seconds. Interesting. So it says that our final velocity v is what? 8.5 meters per second. So you could actually add the meters per second there ourselves if you want to. We can actually do lots of things. So I'll let you do the styling yourself, or the styling, the styles. So meters per second, something like this, and then it will show that to you. If you want it to be close by, you can just add it to it, and then you do that. But this should be fine. So basically, we've created our app. If you don't want to take input from user, you could decide to just comment out the inputs and then just print the initial values you've given. But then if you want to do that, then you should just take the input from the user and then do that. So now if that's added the meters per second for us. So basically that's how we go about the first task. Now up next we move to the second task, and the second task is saying that we should create a C program to compute the formula for standard for simple interest. That's principal times rate times time, right? So in order to do this, we first have to go and then plan, right? So plan our work, and then after planning, we see we plan our work and then see how well okay. So now for this tax will be, so this is for simple interest, right? And then the formula for simple interest is what? Principal times rate times time. All over 100. So principal times rate times time all over 100. Interesting. Now, so which means that our inputs, right? Our inputs would be what? The principal P, which is money. So it's obviously going to be a float, right? Because we have some pesos or cents or what have you. And then the rate is also going to be in floats. And then so floats, bear in mind you can either use floats or doubles, so doesn't matter. And then the time here we'll also use integers, but then the time could also be in years, so it could also be floats, but then I just want to use integers here. But it all depends on what you want. So basically this is it, and then our output will be what? The simple interest. So, and definitely once you are dividing something by 100, the output must be a float, else you'll be getting some chopping. So basically we have that. So which means that now how do we write this for the computer to see? You do the SI, right? And then decide that it should be principal star rate star time all over 100. So you can decide to put all this into bracket and just divide by 100. And then when we are done, we do printf of what? Percentage f, and then print our what? SI for us. So basically that's what you're going to do. If you want to take input, you take, else you choose to just do that. So let's go back to our text, our terminal, and then this time around we would have to get out of here and then create a new file called vim. Let's say this time simple interest. So si.c, simple interest.c. I'm very lazy at naming files, so now we have this simple interest app. The first thing we have to do is do the include, right? That alone tells us that include our standard inputs output library, right? So we have standard input output.h header, and then we use our int main function, but then I'm returning void. I'm not returning anything, so I'll put my void there. And then we want to calculate simple interest, so we declare our float si, and this time I'm not giving it any initial value. So since xi, this is another way of assigning variable. Float, we have si as a float, we have the principal to as a float, so the p, and then we have the rate to as a float, so r, and then time is an integer, so we do our int then time, so t, right? So once we have this, bear in mind you first have to comment to tell yourself in the future that si is for what? For simple interest, right? P is for principal, and then R is for the rate, right? And then the T stands for the time, so T is for the time taken, right? Time. So basically, once this comment will help us to remember what this variable stands for, and then now, so in this, for this exercise, I'll just use initial values and then leave the taking input from user for you as exercise. So I do my principal and then assign it a value of probably 10,000, and then my rate, I give the rate maybe 0.550. Yeah, so the rate is 0.5, and then my time should be what? Let's say 2 years. So okay, 3 years. And then what? Now calculate my simple interest si. Bear in mind we didn't use space, right? So our simple interest is equal to, as we said, principal star rate star what? Time, all over what? 100, right? And then we end this line, and then we just print f of what? This is a float, so we output float, but then we said your simple interest, right? After, so we want after 3 years, so we have to first tell them after percentage d years, right? Is what that. So this is going to be, so go to the new line, comma, and now your simple interest after 3 years. So we first have to call the time, and then what? The si, right? And then let's compile this and see what happens. But then we didn't even welcome the user or the person using our app. We first have to welcome them. Is that something I do? So print f, welcome to my simple interest calculator. Welcome to my simple interest calculator. Alright, so once we've done this, we have to go to print and move to a new line, right? So we've done that. let's see whether we'll compile this without errors. So now let me clear this one. So I do my GCC, but this time around it's going to be what? SI, right? So SI.C, and then I'm outputting it to SI.X. So it compiles without error, which means that everything is on point. Let's try running .si.x. And yeah, welcome to my simple interest calculator. Your simple interest after 3 years is at 5.000. So here too, if you want to just input or output just 2 decimal places, you can do that, because money obviously is around 2 decimal places, so you can just say 2.2f, and then you can do a lot of things, other things to it. But then basically this is that. So for your tax, you would have to remodify this app and then make it accept input from the user. So we recompile. After every editing, you have to recompile first to see your changes occur or effect. So here, after 3 years, is 15.00. Okay, so basically this is how to go about the task. I hope you enjoyed this one, and I hope you've learned something out of it. You can go on and then do more modifications, try and see whether you can take input as I said, and then see whether you can do other things to this to make this great. Thank you very much for joining us in this section, and then please don't forget to like and subscribe if you want to get more of this content, and you can't wait to see in the next video where we talk about loops and then functions. So we'll be using the loops for printing the elements from an array or a string and other stuff. So thank you very much for joining us here, and we can't wait to see you in the next video. Thank you.